In this video, we will finish talking about probabilities. Here are some examples. Identify the sample space of the probability experiment. We have a probability experiment of tossing a coin. So we said the sample space is the list of all possible outcomes. When we toss a coin, we have a possibility of getting heads or tails. This is the sample space for the first experiment. The second experiment is answering a true or false question. So the sample space is all of the possible outcomes for that experiment, which is either false, or true. The third experiment is tossing 4 coins and recording the number of heads. So here we are interested in how many number of heads we get. What are the possibilities of getting heads? So in this case, the sample space is going to be either 0 heads or 1 head or 2 heads or 3 heads or 4 heads, since we have 4 coins. The fourth experiment is answering a multiple choice question with A, B, C, D, and E as possible answers. So the sample space, again, all of the possible outcomes are A or B or C or D or E. The fifth experiment is determining the gender of the first 3 kids in a family. To determine the gender of the first 3 kids in the family, I am going to create a tree diagram to illustrate that. So the first child could be a male or a female. And then the second child, if the first child is a male, could be a male or female. If the first child is a female, the second child could be a male or a female. Then the third child, if the first child is a male, the second child is a male, the third child is either male or female. If the first child is a male, the second child is a female, the third child could be male or female. Similar to the second branch. So if the first child is a female, the second child is a male, the third child could be male or female. If the first child is a female, the second child is a female, the third child could be male or female. From here, we can create the sample space, and we can say that the sample space is equal to all of these possibilities. The first possibility, male, male, male. So we're going to write male, male, male. The second possibility, male, male, female. Male, female, male. Male, female, female. Female, male, male. Female, male, female. Female, female, male. Female, female, female. So this way we can create all the possible outcomes. We can even represent them with a tree diagram without listing the sample space. Another concept that we need to understand is the conditional probability. A conditional probability of A given B is written as the probability of A given B, or P of A slash B. The probability of A slash B is the probability that event A will occur given that event B has already occurred. The conditional probability reduces the sample space, and we compute it based on the reduced sample space. The formula to calculate the conditional probability is given by the probability of A given B is equal to the probability of A and B divided by the probability of the condition, which is B, where the probability of B must be not equal to 0. So it must be greater than 0. For example, suppose we toss one fair 6-sided die. The sample space is going to be all of the numbers from 1 to 6. Let the event A be the face is either 2 or 3, and let the event B be the face is even. To calculate the probability of A given B, we are basically computing the probability that, given that the face is even, what is the probability of getting 2 or 3? So we count the numbers 2 and 3 in the reduced sample space of the event B, which is even. And then we divide that number by the total number of outcomes in the reduced sample space B. So if we do that, you're going to get the probability of A given B is equal to, so now we restrict ourselves to the new sample space. What is the probability that we're going to get 2 or 3 if we are given that we're selecting from even numbers? So here are the even numbers. How many even numbers we have? We have 3 even numbers. How many of these even numbers are 2 or 3? Only 1. So the probability of A given B is 1/3. If we apply the formula, we're going to get, what is the probability of A and B? So what is the probability of getting an even number? And it's a 2 or 3. That is 1 out of 6. The probability here is 1 out of 6. Now, what is the probability of B, which is what is the probability of getting an even number? What is the probability of getting an even number? We have 3 even numbers from the sample space out of the total number of 6. So we basically have 1/6 divided by 3/6, which is equal to 1/3. So the reduced sample space method works as well as the formula that we have for the conditional probability. In the next video, I will show you some examples on how to compute simple probabilities, including conditional probabilities, and comparing them together using the reduced sample method instead of the formula for the conditional probability. The formula for the conditional probability is useful if we already have the probability of A and B and the probability of B. If those were given, then the conditional probability formula works best to answer that question. I hope this video helped you understand the concept of probability, and I will see you in the next video.